Good morning, my YouTube viewers. It is Crystal here, and I'm here this morning to give you a code review because I am studying TensorFlow and Keras. And because I'm studying TensorFlow and Keras, I want to give you a code review on what I've done so far. And basically, the only thing we're going to cover today is the neural network that I created using Keras. But basically, TensorFlow has a lot of other functions and utilities in it that can be used, such as they've got a vectorizer function. But I was up in the middle of the night trying to figure out how to use the vectorizer function, and I couldn't. So whenever I learn how to use the vectorizer function, then I will do another code review on the vectorizer and the neural network. But just for this video now, we're only going to talk about the neural network. But what we're going to do is we're going to go over a program that I've created using TensorFlow and Keras for natural language processing of tweets. So basically, I created the program using Google Colab, and Google Colab is a great platform to use, except for the fact it doesn't have a very good undo function, so you need to be careful not to accidentally delete or overwrite any code. And if you do accidentally delete or overwrite code, you can go into the saved history and you may be able to find the code that way. So what we'll do is we'll go ahead and go through the code review. So the first thing that I wanted to do is I wanted to import the libraries that I would be using from the start, which was pandas as PD, which is for data processing, NumPy as NP, which is for numeric computations, matplotlib.pyplot as PLT, which is for data visualization, and Seaborn as SNS, which is statistical data visualization. I also imported TensorFlow later on in the program, and I imported sklearn later on in the program. So then what we're going to do is we're going to load our library. So df equals pd, that's pandas.readcsv, and I got the tweets off of a GitHub account. Somebody was kind enough to make their tweets public, so I got the tweets from there because I didn't want to use up all the memory in my drive. Oh, I also wanted to say that on a previous video, someone asked me to make the text larger, so I made the text larger for this video so people can see it. So I hope you can see the text well enough, since I've made the text larger and enlarged the text. So you can see df, which you've got an ID, which we don't use, a label, which is either a 0 or 1, and a tweet. Okay, so now what we're going to do is we're going to analyze the label. So the target is your label, and the tweets is the tweet. And then what we're going to do is we're going to put the tweets on the diskplot, or the target on the diskplot, and you can see that we have a class imbalance here. So most of the tweets are 0, but a few of them are 1. And then we put the target, we use value counts from the target to count. So you've got 29,720 zeros and 2,242 1. So that lets you know there's a class imbalance. Now we do our data processing. We import re, which is an inbuilt library in Python, which is for strings. We import NLTK, which is a natural language toolkit. We download the stop words from nlt.corpus. We import the stop words from nlt.stem.snowball, import snowballer. So stemmer equals snowballer, language equals English, and words equals stop words dot words English. So we're going to stem it in words. Okay, so then what we do is we're going to have, you also have something called Lemonizer, which I didn't put in this particular program, but you can also use a Lemonizer as well. So tweets equals tweets.apply, lambda x, blank space dot join stemmer dot stem I for I in read dot sub, then A to Z in brackets, and then blank space, comma X. So what that's saying is anything that is not one of those characters, it's just going to be a blank space. And then you're going to split it if I not in words. So if it's not in the stop words, and then you're going to make it lowercase. So then we're going to print the length of words, which I think that's the length of the stop words, which is 179. You get 179 stop words. So now what we're going to do is we're going to process the text. So we're going to make it lowercase, and then we're going to remove punctuation. We're going to remove hashtags. We're going to remove words less than 2 characters. Okay. We've got a warning here. The default value of regex will change from true to false in a future version. Tweets equals tweets.str replace. So that's going to happen in a future version. It's going to be false. So that means that we'll have to change that code. See what it says here. String replace. So we'll have to see how that's going to affect us. And then what we're going to do is we're going to remove the rare words. And so these are words that appear only once, because the model cannot predict on something that appears only once. So there's no point having it in the corpus. So we're just going to remove it. And now what we're going to do is we're going to define X and Y. So those are your independent and dependent variables respectively. So Y equals NP array target and X equals NP array tweet. And then we check the shape of X and Y, and they're both 31,962. And now what we do is we use sklearn's train test split to split the data set up into training and validation sets. And then we also check the shape of X train, Y train, X val, Y trail, and you can see that. And now we use sklearn's TF-IDF vectorizer to vectorize the data. And so with TensorFlow, they also have a vectorizer function, but I'm not really sure how to use it. I was up in the middle of the night trying to figure out how to use it, and I couldn't figure out how to use it, so I'm going to have to practice some more on that. But when I learn how to use the vectorizer, I definitely will do a video on it. But from sklearn feature extraction text import TF-IDF vectorizer, vectorizer TF-IDF equals TF-IDF stop words equals English, max DF equals 0.5, min DF equals 0.01. So X train equals NP array X train to list, X train equals list map join X train, xval equals NP array xval to list, xval equals list map join xval. And the thing about this is because all of these libraries are continuously changing, so I did not always have to use this code. It's only recently that I've had to use the code. So basically, I think that sklearn changed, and when sklearn changed, you have to use the code. And then you say xtrain TF-IDF equals vectorizer TF-IDF dot fit transform xtrain, and then it has to say dot to array when you're dealing with TensorFlow. xval tfidf equals vectorizer tfidf dot transform xval to array. So what you have to do is, because if you're going to be putting the data into a neural network with TensorFlow, it has to say to array, otherwise the neural network won't work, and I found that out as well. So you do have to modify the code to make it work on a neural network. And then we've got the shape for all the 4 data sets, and you can look at the shape and you can see that they're correct. You've got 74 columns in X-train TF-IDF and 0 columns or 1 column in Y-train and X. And then now what we're going to do is we're going to say feature len equals X-train TF-IDF shape 1. So your feature len equals 74. That means you've got 74 columns of data. So now what we're going to do is we're going to build the model. And this is your neural network. Okay, so import TensorFlow STF, import from TensorFlow, import Keras, from Keras.models, import sequential, from TensorFlow.Keras.layers, import dense, and you can see the version of TensorFlow they've got is 2.11. And now we're going to create the model. Model equals sequential, model.add dense 500, input shape equals feature len, activation equals reload. But I think I made a mistake there. I think on the dense equals 100, I don't think that you need input shape equals feature len, activation equals reload. But when I finish this code review, I'm going to type the input shape equals feature len, because I don't think that you need it. So, but if I rerun it, it's going to take a while. We'll go ahead and rerun it. See what happens. See what happens when we rerun it. So I think you only need the input shape on the first one. You don't need the input shape on the subsequent ones. And then so model.add dense 1. So 1 is your output, and you only got 1 output, and activation is sigmoid, and sigmoid is what you're going to use when you want binary classification. So then we compile the model, model.compile, loss equals binary cross entropy, atomizer equals atoms, metrics equals accuracy, and then we print a model summary. So you can see the model summary here. So now what we're doing is we are actually training the model, but what I did was I set it up for verbose equals 0 because I didn't want to see everything. And the reason why is because I'm going to be making a blog post on this, and whenever I make the blog post, you know, it just doesn't look good to have all that stuff there. So we just have to wait for it to run its course, and it will run its course at some time, and we'll just have to sit here and wait. Hopefully it won't be too long. It's only 50 epochs, so it's not going to be too long. If I did 500 epochs, then it would be really long. But model.fit X-train TF-IDF Y-train epochs equals 50. So an epoch is an iteration, and batch size equals batch size, and batch size equals 32. Verbose equals 0 means you can't see what's happening on the screen, which is something that I don't want to see, because it just makes the program so much longer when you've got all of that information on the screen. And shuffle equals false, so we're not going to shuffle it. And now we're going to check the validation loss. Validation accuracy equals model.evaluation xval tfidf yval. So we just have to wait for it to finish. And then we print our validation accuracy, and then we print validation ACC. And now what we're going to do is we're going to make predictions. It's still just churning away. So it turned away. So we've got a 93.46% accuracy on xval tfidf yval. So that's good. So we've got And then what we do now is we're going to make the prediction. So ypred equals model.predict xval TF-IDF greater than 0.5.s type int32. And if you don't put that in there, then what is going to happen is you're just going to get a floating point number between 0 to 1. So in order to keep you from getting a floating point number from 0 to 1, you have to say model.predict xval TF-IDF greater than 0.5. Now, if you have more than two classes, so if it's a multi-class, then you're going to put the code down below. So you need to be careful. So the first code is if it's binary, and then the second line, which I've remarked out, is what's going to happen if it is more than two classes. So we got our ypred, which is zeros and ones. Check the accuracy on ypred is 93%, which we've already done that previously, but I just did it again. We check our confusion matrix. So confusion matrix tells you how many zeros you got and how many ones that should have been zeros, and how many ones you got and how many zeros that should have been ones. So what that's saying is that this model didn't do a very good job with the class imbalance. So what I'll need to do is I'll need to investigate and see what I can do with the model to work on a class imbalance. Then we've got our confusion matrix, so you can see the confusion matrix. And then we've got a data frame to compare the actual value against the predicted value. So that was good. So we know doing this code review that we need to find out what we can do in a neural network to improve the class imbalance, because that's what we've got. We've got a class imbalance. So I'm going to go ahead and conclude this video, and I hope that you got something out of it. This is for a beginner, and I'll be studying TensorFlow some more. And as I study TensorFlow more and I learn more, then I will be making more videos for you to help you on your TensorFlow journey, because from what I understand, TensorFlow is actually more popular than sklearn. So I would like to thank all of my subscribers for supporting my channel. If you like this video, please like, subscribe, and share. And thank you again for watching my video.